There we go. I was having a hard time with this the other day, but we seem to get it. We've got it all figured out. Cool. Now I can move my head so that I'm looking at you. Okay, so we are in lesson 11 of unit 4. Hold on, let me pause this because it was really dark. I didn't want it to be so dark. I'm in my office at home. So we are still looking at domain and range, and the goal today is, let's see, draw, pen, a little bit smaller. So given a description of a function, that represents the situation, and you can write this down with me, right? Situation. Determine a reasonable. Determine a reasonable domain and range. Okay, so same objective as lesson 10, just taking it one step further, extending it. So let's look at which one doesn't belong. Unlabeled graphs. All right, these are the ones I love doing in person because they're so much fun. We could say anything. We could say A doesn't belong because it's a continuous line, that the slope is decreasing, it's negative, it has a vertical intercept, a horizontal intercept, etc. We could say that B doesn't belong because it's what we call a piecewise graph with holes in it. We call this also a stepwise function. Oh goodness. Because it looks like steps. We could say C doesn't belong because it's horizontal. It only has a vertical intercept, no horizontal intercept. The slope is 0 because it's horizontal, and Z's have 2, sometimes 3 horizontal lines in them. Or we could say D doesn't belong because it oscillates. Oscillates like waves. It's a wave function. Yeah, could be anything. Moving on. All right, time in the swing. So a child gets on a swing in a playground, swings for 30 seconds, and then gets off the swing. Here are descriptions of 4 functions in the situation and 4 graphs representing them. The independent variable in each function is time measured in seconds. That means that the x-axis, which is your independent variable, is time measured in seconds. Okay? Now, match each function with a graph that could represent it. Then label the axes with the appropriate variables. Be prepared to explain how you got your matches. All right, so we have function h, the height of the swing in feet as a function of time since the child gets on the swing. So the height of the swing in feet as a function of time since the child gets on the swing. And think about that child. Like, I don't know, I'm not going to be very good at drawing this, but we've got, you know, a swing set where, you know, we've got the swing. And if I did the side view, we would have the swing with the child sitting on it and her feet kicked out, right? As we did the height, she gets on the swing, and then the swing goes this way and that way, etc., etc. So the height would, the height of the swing, so the height would get higher, shorter, higher, shorter, higher, shorter, right? In fact, when that child first starts swinging, she's going to start just kicking her feet a little bit, and then each time she's going to go further and further and further until she reaches the top. Oops. And then she gets shorter again, like maximum and then back down to the minimum. Well, that kind of looks like this one, right? Because the height of the graph, it's always going to be at a certain height. So, I mean, if this is the girl, right? The minimum height is going to be the same. Can't go any lower than that. So that's going to be the same as this minimum height. And then she's going to kick and go taller and taller and then back down to the minimum height. So here, the height, it's like she's swinging. The height gets a little higher, back down to the minimum, higher, higher, higher. She's kicking her feet harder and harder and harder, higher, higher, until she gets to the maximum, and then back down. That's definitely H. Function R, the amount of time left on the swing as a function of time since the child gets on the swing. So, lots of time. So time left on the swing as a function of time since the child gets on the swing. So she gets on the swing at time equals 0. But at time equals 0, she has time equals, I don't know, mom's letting her swing for 15 minutes. Well, as the, let's see if I can delete this. I need to draw again because my drawings are so amazing. I know. So we think about, it already said that the independent, this is time on swing. If we made this time until time is over, time runs out, is that what it said? The amount of time left on the swing. Let's use the right words, we can do that. Oops, lost the vertical axis. So time left on swing. Well, when she gets on the swing, she has all the time left. And as this time increases, the time she spends on the swing, well, the time she has left on the swing goes to 0. Okay, until the time left on the swing is 0 and the time she's been on the swing is maximum. Okay, so that's definitely R. The distance in feet of the swing from the top beam from which the swing is suspended as a function of time since the child gets on the swing. Okay, let's erase this stuff. I assume you're drawing your own pictures and taking your own notes. And if not, you can always rewind it and write them down. So here we have the distance in feet of the swing from the top of the beam from which the swing is suspended as a function of time since the child gets on the swing. Let's look at that. Because, I mean, I want to say H again, but no. Oh, the distance, so that is just one value. What's it called? D. So the distance in feet, the distance in feet of the swing from the top of the beam. So what we're talking about there is if we have, I mean, I can't really do a side view, but if we have the swing, it's really talking about the length of the rope. So as that swing, if I did that side view again, so there's the swing, there's the girl on it. So it's the distance from here to the swing. As she swings, that distance really doesn't change. It's constant. So that's that one. I get it. The total number of times an adult pushes the swing as a function of time since the child gets on the swing. Total of times an adult pushes. So here, that's this one. So if you think about you push, you push, you push, right? You push. Okay, so that's definitely that one. Wants us to do something else now. On each graph, mark 1 or 2 points that, if you have the coordinates, could help you determine the domain and range of the function. Be prepared to explain why you chose those points. So here we're looking at domain and range. Remember, the domain is our input for all of these. The x-axis is our domain, the y-axis is our range. If I wanted to determine, I'd really want to look at like where it crosses the axis. Okay. This would be considered my maximum point for the range, so it's definitely going to help me determine what type of range. This would be my maximum point for the domain. minimum point for the range would be here, all on the vertical axis. So I've got my maximum point and my minimum point. And then here I have my minimum point and my maximum point. Those will help me determine. Here, same thing. Like if I look at the vertical axis, I trace this one back. This is my max. It's going to help me determine what type of range. And there's my min. Same thing here. I've got the min and then my max. One value for that one, right? And then the domain, I mean, that just keeps on going. It never changes. Domain might be all real numbers, which is how I draw that. Okay, again, my maximum, my minimum for my range, that'll help me determine it. And then this whole thing for my domain, the minimum and the maximum. Then once you receive the information you need from your teacher, describe the domain and range that would be reasonable for each function in the situation. I'm going to give that information to you right now. All right, let me grab it. All right, I found it. So here's information that you guys will need for the last question. So the child is given 30 seconds on the swing. I'm going to make a list. 30 seconds on the swing. While the child's on the swing, an adult pushes the swing a total of 5 times. The swing is 1.5 feet above the ground. That's the seat the child sits on. The chain that holds the seat and suspend it from the top is 7 feet long. 7 feet long chain. All right, so now we want reasonable domain and ranges for these functions. All right, so if we look at the first one, H, that was the child swinging back and forth, right? So the range, let's just do a different color. I haven't used green yet. So my range is going to be all numbers from 1.5 to 7. All right? All numbers from 1.5 to 4. Hold on. Where did we get 4 from? Let's go back and look. So the 7 foot long chain, 1.5 feet above the ground. Why would that be 4? Because it's just reasonable. That's just reasonable. So this being 1.5 is given in our information, but this right here is just reasonably 4. Okay? Let's look at the next one was R, the amount of time left on the swing. That's this one. Our range, did we do domain? Nope, we're just doing range. So the range here would start at 30 and go to 0. So our range would be numbers ranging from 0 to 30. All numbers ranging from 0 to 30. And then we have D, the distance in feet. The swing is from the top beam. Our range is just 7 feet. That's the only reasonable value for that one. One value, that's it. And then the last one, which are the pushes. So our range, which is right here. Oops, I pushed a button on my pen. Integers from 1 to 5. We could also say whole numbers from 1 to 5, right? Only whole numbers. Ah, I'm wrong. From 0 to 5. You guys would correct me if we were in class together, wouldn't you? Yeah. Okay. Cool. Back to to the bouncing ball. A tennis ball was dropped from a certain height. It bounces several times, rolled along for a short period, and then stopped. The function h gives its height over time. Here's a partial graph of h. Height is measured in feet, time is measured in seconds. Use the graph to help you answer the questions. I'm going to get the right graph up here. Be prepared to explain what each value or set of values. So first we're going to find h at 0. So that is our input of 0. This right here is our input of 0. So our h at 0 is right there. And I saw this in some of your homework problems. If we wanted to put that in function notation, we would say h of 0 equals 6, that ordered pair. So my height at 0 is 6 feet. And then solve h of x equals 0. So when the output is 0, what is the input? All right, so here my output is 0. What is my input? Let me erase this. When my output is 0, what is my input? Well, my input can be 0.5, 1.5, 2.25. I don't know why I put a dot in between that 2 and 5. 3, or whatever that value is. All right, so h at 0, how do I want to write that answer though? Yeah. So h at 0, solutions are 0.54. I'm reading it right there. 1.48. I read it right there. 2.25. 3, and I don't know, 3.27. Oops, 3.27. Something like that. Okay? Those are all possible answers to that. Any one of them would be correct. Describe the domain of the function. Domain is my inputs. Okay, it's the time in seconds. How would I describe that? We could say the domain includes, and I'm showing you how I expect it how I expect it to be written. The domain includes values between 0 and the time the ball stopped moving. It doesn't show us because of that right there. The time the ball stops moving. Cool. Now describe the range of the function. The range is this side. The range includes values between 0 and 6 feet, which is the height from which the ball is dropped. Makes sense. And it's any values. Doesn't have to be whole numbers or anything. All right, we aren't going to use those right now, though. So that is it for lesson 11. Nice job.